Hello, my name is Layde and I'm PhD student under Simone's advisor. Today we are going to present our project named Obtain catiônico polymer Pululana-DEAE-graft-poli for future application in cancer treatment. Cancer treatment nowadays need to be developed with new technologies due to the low bioavailability of the drugs, response for the poor solubility of the drug. Modified pharmacokinetics is necessary to improve the biodistribution of the drug during the therapy, and targeting is a new technology that has been developed for modifying this pharmacokinetics. Target therapy reduces the accumulation of the drug in the normal tissues and cells and increase this accumulation in the sick cells. Minimize side effects is one of the benefits of this technique, and besides the extended time of the drug in the bloodstream. The use of stimulus-sensitive material is one way to use the target therapy. Implementing cationic copolymer for the cancer treatment is one way to use stimulus-sensitive material for the target therapy. Cationic copolymer can be developed to encapsulate drugs and act in the organism to deliver the drug exactly in the cells that has different values of pH. Usually this kind of cells is the cancer cells. The main goals of this project is to synthesize Pululana cationic copolymer as an example of biodegradable and biocompatible particles, and for that we need to modify with DEAE. After that, graft copolymerization with lysine NCA monomer, and future development of the nanoparticles and nanocarriers for cancer treatment. The methodology developed was synthesis of Pululana-DEAE with the presence of sodium hydroxide, followed by the copolymerization with NCA-lysine, obtaining Pululana polylysine DEAE. For the characterization, NMR was used, and we can see the remaining presence of the hydrogen from Pululana, that the DEAE didn't modify the whole Pululana structure, and we can see the signals correspond to the DEAE. The signals correspond to the DEAE material grafted in the Pululana's backbone. We also can see after the copolymerization signals corresponded, for example, aromatic ring of the monomer. Other technique used was FTIR. In the FTIR we can see bonds representing the modification of Pululana with the copolymerization of polylysine. Even though we didn't see any modification with Pululana-DEAE, we could see that in the NMR. And Pululana-DEAE-polylysine, it could be seen the difference between the spectrum and the presence of carboxyl stretching. Other technique used was DSC, where we could see the modified temperature values after the modification and copolymerization. There was a change in the TM values, in the melting temperature values. And analyzing the results, we could see that Pululana-DEAE and polylysine was synthesized according to our expected, and we had the thermal properties modification of copolymerization, and the material is now ready for application as a nanomaterial for the delivery drug treatment.